This na radio lesson on top 95.1 Wazobia FM.
Welcome back. We're still talking about metals, and my name again is Monininola Adijobi. Now we want to look at a few questions you may come across in your external exams under this topic of metals. Now let's take this first question. State 5 differences, physical differences between metals and non-metals, with emphasis on their physical properties. And let's set the ball rolling again. Number 1, all metals have what we call metallic luster. That is the shining effect you see on metals, but non-metals don't. Number 2, metals are good conductors of heat and electricity, and that's why they are used as utensils to heat substances. But non-metals are not good conductors of heat and electricity. In fact, they are poor conductors. Number 3, metals have high melting and boiling points, but non-metals have low boiling points and melting points. Number 4, metals have what we call a high tensile strength, and that is why they can withstand a lot of stress. That's why they are used in construction. That's why they are used to carry heavy loads. But non-metals have very, very weak strength. In fact, they don't have any tensile strength at all. And number 4, metals are malleable. That means they can be beaten in to give you different kind of shapes. And I'm sure if you look around the room where you are, you find metals of various shapes. But non-metals are not malleable. And the next point on that is that the fact that metals are ductile. That means you can readily pull them into thin wires. But you can't do this with non-metals. And that's that on that question. Let's quickly pick another question. Now, quickly summarize the reaction of metals with water. And for us to be able to do this, we want to classify metals into 3. The reactive metals, the moderately reactive metals, and the non-reactive metals. For the reactive metals, we have sodium, calcium, and potassium. These ones will react with cold water to give you the corresponding hydroxides and hydrogen gas. That means sodium will react with cold water to give you sodium hydroxide and hydrogen gas. And then the moderately reactive metals. These ones are magnesium, aluminum, zinc, and iron. These ones will only react with steam and give you their corresponding metallic oxides and hydrogen gas. And then we have the non-reactive metals. These ones are essentially gold, mercury, sometimes copper and lead could be classified into this group. These ones will neither react with cold water nor steam. They would not react with water in any form. There is, however, one of these heavy metals. Sometimes it's classified as a non-reactive metal, tin. Tin on its own will react with steam to give you tin oxide and hydrogen gas. Quickly, let's take another question. What compound do you get when metals burn in air or react with oxygen? Metals, when they burn in air or when they react with oxygen, will give you their metallic oxides. Another question quickly. When a metallic oxide is dissolved in water, what do you get? You get an alkaline solution. And that means that alkaline solution will turn blue litmus paper to red. Let's take another question. What type of solution do you get when a non-metallic oxide is dissolved in water? You get an acidic solution, which will turn blue litmus paper to red. Sorry, let me quickly make a correction. The first one I said will give you an alkaline solution. An alkaline solution will turn your red litmus paper to blue, but an acidic solution will turn your blue litmus paper to red. I want to believe you've been able to pick one or two things again, and then we will be taking just one more question before we go on a time out. And that is this. Let me pick the uses of metals. And I want to talk about sodium, for instance. Sodium, as a metal, is used to produce a lot of sodium compounds, like sodium hydroxide, which is an alkali that is used in titrimetric analysis. Sodium also is a major component of sodium chloride, which is used as a food preservative or as food seasoning. It is also used in glazing of pots. Sodium is used to produce your baking powder, and the chemical content of your baking powder is simply sodium hydrogen trioxocarbonate 4. Again, sodium is used to produce sodium trioxocarbonate 4, which is a strong alkali in titrimetric analysis, and at the same time is a major substance that is used to soften water. And then another thing that sodium is used for, in generally, sodium hydroxide is also a major component of the soap. I'm sure you have used soap this morning. So anytime you handle any type of soap, particularly laundry soap, sodium hydroxide is a major content, and it is a product of a metal. And before we time out, I want to say something about sodium. It's a very, very reactive metal. It should not come in contact with water, because it's going to give a very, 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 very explosive reaction. So when next you get into the lab, please be careful. In fact, you find sodium as a metal stored under liquid paraffin, because it must not come in contact with moisture. Thank you once again. We'll be coming back.
95.1 Wazobia FM and the Lagos State Ministry of Education bring una this lesson.